So previously we looked at that our model predicts the house price of 290, but is that accurate? Well, we looked at the actual data. So when we supplied a house size of 1000, it predicted 290, but the actual price is 300. So is that good enough? Difference of 10,000. And this is where we look at how do you judge the accuracy of your model. So in terms of judging the accuracy of the model, you have to split your data between training and testing. So for training, we used some random values from here, and for the data for the prices as well. And then we selected some for testing, and we selected 20%. So now, in order to judge the performance of accuracy of the model, so we put in, for example, if you look at this, we asked the model, so model.predict, and we passed it a size of 1000, okay? And it predicted, so then in the next line, this is the predicted price, we just basically printed that price. So when you look at this bit, the predicted price, you need to judge, is this correct? So one of the things that you need to look at is the feature importance. So the feature importance here is what would the price change by for every time the size of the house increases by whatever unit that you've specified. So in this case, the unit that we specified is in square feet. So for example, this is 650, 800 square feet, this is 1000. So every time it goes up by, the house price would go up by this amount, so 0.211. And then you can see the intercept value. This is what the base price would be. So the intercept is the base price, the starting price of any house. So a house with 0, for example, size, or 1, this is the minimum price. So this is like the standard. This is where you would start off the bidding, the minimum bidding price, what you might say, for example, like on an eBay auction. So that's the minimum amount it would take. And then you have something called the R2 value. So this is the value that actually shows you how accurate your model is. So in this case, if it's closer to 1, so this is 0.9, and if you were to round this up, this would take you to 1%, 1.0, 100% accuracy. But remember, no model should be 100% accurate, because otherwise it's too accurate, too good to be true, in effect, because it's overfitting your data and it's following your data, which isn't good. So here you can see that actually our model, by just this value alone, is pretty accurate. And next we'll look at some of the other options, which is the mean absolute error and root mean squared, to just dig that into a bit more detail. And we'll also look at this chart and explain how it works. So remember, the house price that we got here, which is predicted based on 1000, is 290. We know the actual price of that is actually 300, but we got 290. But we can see, based on the model output that we got with the R2 value, our model is pretty accurate.